Okay, we have a MacBook Air. It's a no power. So here it says it's no power. So as usual, so let's see what the okay. So it's a MagSafe 2. So definitely it's going to be from 2012 up until 2017 because it's a MagSafe 2. Please close that. We are not going to connect power to it as usual until we confirm what's happening inside. This is coming in from another company, which assessment has been done. After the assessment, only then they come to the conclusion that it's whatever it is written here, or whatever it's written as the final description. It's something that they get after the assessment. So, and we are fairly confident that the assessments that they do consistently has been correct. Okay, so backover is out. Okay, so this is just coming in. So it says flux or liquid. Let's see. Okay, looks like flux. Looks like liquid. Okay, so this is going to be a 2015 or 2017, given the GTEC that we have. So quickly, what we are going to do is because we're not sure exactly what's happening on the other side of the board, we are not going to connect power at all. So let's just take the board out quickly to see what is happening on the other side of the board. So we're not sure if this is liquid or it's been through an attempted repair. So let's take the board out so that way we can tell which is which. So you see, usually I do not take out the DC jack because I just leave the DC jack in the shell because I use the one that's already out, so I don't have to use the one from the clients. So the only time you obviously take the DC jack out would be when there's a need to do so. But other than that, you leave the DC jack in place. You know which is the DC jack?
No, please.
He's not showing you what a DC jack is. That's very basic. So what has he been showing you if he has not shown you what is a DC jack? What has he been showing you if he has not shown you what is a DC jack? Okay, so this is a 2017 board, and this is liquid and not. So the two things I see happening here. So here will be liquid. That's liquid. But here it's been. I'm not sure what was happening here, but that isn't that and that not the same. Okay, let's remove let's remove the card as well. I think we also advise them to replace the card, even though the card will still work, but it would be best to replace it. Now, there's been previous work done here. See, this capacitor also was replaced, but I'm not so. But what seems here is that this capacitor seems like the work that has been done before the liquid is this is inconsistent with now because this is layered on top of the soldered component, so which is that came afterwards. Okay, so area of concern, we see we have a liquid here. That's going to be the SMC research region here. Here it's going to be the PP340 region, And then another thing also is this. So when you have liquid around your JTAG, this JTAG is basically like the central communication point. I never spoke about the JTAG, but I only told about how you can identify the JTAG from the small to the big, and what how you can draw information from that. However, the JTAG it's more of um, a communication medium that allow you to connect and communicate with this board. So say for example, say I want to say this here, this connector here gives me access to this board. Let's say for example I want to access the board. Say I want to unlock or I want to modify the ROM on this machine. So I can get a cable that plugs into that connector, and it will give me access to the board without me having to remove the board from the shelf. So say for example I want to interface with this chip here, which is the ROM chip, correct? Instead of me having to physically remove the board and remove the chip, I can interface with this chip by plugging a cable to the JTAG connector. That's one of the things you can do with the JTAG. So now the JTAG itself, its purpose, some you can say debug, so which is basically it's more like you can use it for debugging, but then it does not really it's not something that is actively being used by the client. It's not an active part of the machine. Whether it's present or not, it's still going to, the machine will work 100%. However, so the reason why I'm talking about this is if you have corrosion on your JTAG, it can prevent your device from working, and it can actually make your device, you can get all kind of behavior from your device just by having liquid or corrosion on your JTAG. Don't be surprised that you have liquid or corrosion on your JTAG and the board looks extremely clean, but the board will not start. And the only thing you need to do is to remove the JTAG, and then your board will start working. So our area of concern is going to be, we don't see any type of corrosion. Yes, we see there's liquid around it, but we don't see corrosion. But that's going to be an area that we also want to look into. This is a PP3V42 circuitry. We're going to look into that. And this is the SMC reset. We're going to look into that. And then on the other side, we have the clock chip, which is not much, there's not much of a effect happening there. And here we don't really have anything that is being affected. So so what we're going to do quickly is we're now going to see what is it that is happening on the board in terms of what do we have of voltage. So that will determine what we do. So the areas that I just pointed to, let's quickly open up our board view. Do you remember what the board number of this machine is? The 2017-2016 board? Remember the board number?
Oh, I can't remember.
Okay. 00165. 00165.
Yes.
It is 0-00165. Okay, so I talked about this region here, the SMC reset region. We have liquid here, so we are going to look into that. So if we have problem here, what will, if the SMC, if that is low, what will happen is the device will tell the SMC to be in reset mode, which would then prevent the device itself from working. And so we are going to check that, and then we're going to see if we have PP3V42. E1790 is going to be our PP3V42 generator IC. And we have an inductor here, so we're also going to check to see if we have a PP3V42. And obviously PP bus will be 8.2 if SMC is in reset mode, but it is going to be 8.6 if SMC is not in reset mode. So if we find 8.6 in our PP bus, then we're not going to worry about the SMC being low. We're also not going to worry about PP3V42. So if we get 8.6 here, definitely PP3V42 is present. SMC reset mode it's high. The reason is PP3V42 and SMC reset mode will be required in order for you to get your 8.6. Your PP bus will be 8.6, because if you don't have PP3V42 and your SMC is in reset mode, you will not have 8.6. So let's quickly see what is it that we have on our PP bus. So checking the PP bus will give us, instead of having to check both PP3V42 and SMC reset, so PP bus will give us So if I'm talking about the board, camera will be on the board. Obviously, I mean if I'm talking about this thing, so it means it's very common. Okay, so charger is connected. We are not expecting to have LED on the charger. Why? Because we do not have the IO board cable connected. The LED on the charger, the IO board cable, it's going to be required. It needs to be present in order for the LED on the charger to be active in a normal working condition. So let's have our black loop on ground. We set our multimeter is on voltage mode. First thing first, we want to confirm that indeed we have voltage coming from the charger that we can use the DC jack. So we'll check on the DC jack. We have 16 volts. So that tells us that we have voltage coming in from the charger. The next thing we want to see is to see what is it that we have on our PP bus, which is we can check this fuse here. And then another thing is when I'm pointing to small components, you have to come closer. Otherwise, you yourself, if you are watching the video, how are you going to see? I mean, small components, the view of that is not the same as a big one. So if I'm talking about small components, you have to come closer so that you see what I'm talking about. So I'm going to use this fuse here. So let's see what is it that we have on the fuse. We have 8.5. So 8.5, it means because we have 8.5, so we're not going to worry about the SMC reset because that is going to be fine. We're also not going to worry about the PP342 because if we didn't have PP342 and the SMC, we will not have our PP bus will not be 8.5. 8.5, 8.6. Okay, so, and then on the other side, let's see what we have on the other side. Okay, that's fine. So let's see if the device is partially making its way into SO state. Device is trying to make its way into SO state. You see that? So it's fluctuating. So you get like a quick say. Okay, so let's see. Do we have our source rail present? And that's also fluctuating. Source is also fluctuating. Okay, so let's see let's see. Let's check. See what we have on our SMC. SMC reset L seem to be fluctuating as well. Okay, let's see. Okay, so SMC reset L seem to be you seem to be getting a fluctuation around SMC reset L. So let's uh, let's let's remove this guy here. U50 100, U50 U510. Let's remove it. See if we will get the same behavior. So what we are getting is let me just show you what we're getting so that you know you're on the same page. So we had already said that the area of our focus will be this section here, which is SMC reset L, PP342, and this is also going to be an area of concern. And then we said that we will be using the PP bus fuse. Using the PP bus fuse will allow us to basically override or to confirm what's happening here and here. So what we see, so with charger connected, we do get PP bus to be 8.6. However, we have a bit of a cycle on. So let's just do this. So you see, we have PP bus, which is 8.6, which tells us that SMC is actually the PP3 photo is present. But then you see that it drops, correct? So it's almost as though now when we walk back. Remember, this circuit is for SMC reset L, correct? If you go check out the SMC reset signal, we can check it here. We're getting about the same thing. It's supposed to be 3.4, but it goes high and quickly go low. So which means most likely that chip might be doing that. So let's quickly remove that chip and then check again. Okay, that's out. Before we, so let's see what happens. Just we're not going to put it back yet. Let's see what we get now. Um, 3.9, that's fine. Not expecting it to be. Just let's see what we have. I'm interested in the same series L. See if it's stable or fluctuates. No longer fluctuates, correct? Okay, so can I have another board quickly to replace that? What board did you give me? Is it a 00165 or
Yes. 00167.
okay? Is the component on the board the one that we're looking to replace? The component that we're
Yes.
looking to replace, is it on the board? The board that you have, is it on it?
Yes.
Okay. Okay. Okay, that's there. And we know usually when it comes when we are busy with a no power on MacBook Airs, especially, I make sure that I don't have the fan connected because I want my multimeter to tell me what's happening. I don't want to look for fan spin. I don't want to give myself in a heart attack. Okay, so let's see. SMC reset L. We know that was fluctuating. Let's see what is it doing now. Stable. Okay, then another thing I want to quickly make mention of, the reason why you see I'm kind of locked here is because of what I saw liquid being in that section. Now, in terms of the SMC reset also, the circuitry that controls that basically will be directly the SMC itself or the SMC reset or this chip itself. So if you get in SMC reset, so if I yes, I was still going to start from here, but then the reason why I'm locked here and not going to the SMC to kind of give it a bit of a reflow is because I see liquid in that section of the board. So okay, so we know that that seems to be stable. Now let's see what's now. Wait, what is that? 3.9. Ah, okay, okay. And the other side? Okay. We now have a short on the side of the. Okay, that's interesting. Hmm. Okay. Let's see. We're supposed to get um, zeros all across, but we're getting 003. So we have a bit of resistance. Okay, let's see. Do we have a short? No, we don't have a short. Okay, let's quickly replace that as well. we can replace this, or if you don't have this, you can use you can just put a wire across it. If you don't have a replacement, because it's a fuse, you can just put a wire across it.
But I'm not, just a while ago, I'm not sure if it went through, so I've WhatsApp but no one replied. Okay. Can I keep this? We are 3 hours away from Cape Town. So we stay for tonight. And then we're leaving again in the morning. So I don't know if you guys will be able to check for us and maybe if possible then it can be ready. Okay. So basically I'm gonna give you the form that we because we originally wanted to give it in a digitape and then I saw you guys in Mesh. So all of the details in there what the problem is. Is the power up and
Okay, so that is that. Let's now see. Let's check to see.
what is the problem like that? Huh?
See the other one we had supposed to be zero zero. The other one, this one, the one that we had, we were getting a bit of resistance across it. You see that? We getting a bit of resistance across it. But this one we don't have any resistance. That's how we should be. Okay, so now let's see.
I just want to give you myself a number. I just want to give you myself a number. Because he's did it online, but I'm not sure.
Just confirm that we have to be the same voltage. That's fine. Let's see what you see that we have on that. That's at 8.5, and then the other side, 8.5. Say the other one was giving us 8.4 volt, correct? But this we're getting 8 volts on both sides. Now let's see what is it that we have on. Let's see, and then you have 5 volt, so which means our device is now powering on. Okay, so now we can have a charger, the fan connected. Should have a spin. See, now we have a working machine. So let's quickly just test that device is because it's one thing to have a spinning fan, is another thing for the device to actually post. So let's confirm that the device is posting. Also, it's going to be important to point this out when it comes to collect that there is also liquid in this section of the body.
Yes. What causes that erosion?
No, that's corrosion. Erosion, yeah. It's liquid spinning. Somebody spilled something on it.
Oh.
Uh, fan spin. We have a fan spin. Let's see, do we have anything on the screen? Okay, that's about it. It's completed repair. I'm just gonna go just a bit of an explanation of what we do, what we did, and why we did what we did. So we found liquid in this section of the board and this section of the board, as well as this section of the board. And then we checked the other side. Everything seemed to be fine. So when we started our measurements, we said we can easily bypass this and that by checking what is it that we have on our PP bus. So we checked our PP bus. We're getting 8.5, 8.6, what we should have, but it was quickly dropping. So, which would mean that you have some kind of a reset signal being sent through. So, what we did was we then had to go to our reset signal, and the reason why we took that route was because of liquid, the liquid in this section of the board, correct? And then, given what this is supposed to do is to basically so when you have a problem there, you have the SMCB in reset state, which in that case the SMC is not going to work. So we went to check here this test pad here to see if SMC reset L is low, and then that also it was fluctuating. It was 2 point something instead of 3.4, and then also we use the charger reset L because it's being pulled up by SMC reset L. So the signal that we measure here is supposed to come from SMC reset L. So which is if SMC reset here L is low, it's also going to reflect here. That's why we use this pad here. So when we saw that, what we then had to do was to remove U51. Then after we did that, the signal was stable. So we then went ahead to replace it. And then after we replaced it, we checked. Now we started to have not a short. So we have 8.6 volt here, but here we're getting less than that. So we checked the resistance across, and then we found there was a bit of a resistance across it. It's not supposed to be any type of resistance because it's a fuse. So we then had to replace it with another one. After replacing it, we checked and it's fine. And then we checked the machine. Now we have a fully working machine. The next thing we're going to do is just basically clean the liquid that is out. But other than that, as you guys can see, the device powers on. We have an Apple logo, and then that's about it, guys. Do you have any question before we finish this one? Any question?
Those, I understand.
On your side, any question? That's fine. Okay, thank you, guys. I'll see you guys in the next one.